In the last several units, we talked about ways to go about creating alcohols as reaction products, or in other words, we talked about alcohol synthesis. In the next several units, we're going to talk about reactions that alcohols undergo. Reactions of alcohols are extremely useful because they are going to lead to a wide variety of different functional groups that we can create in the product. So in other words, alcohols are really useful starting materials for doing a variety of reactions to introduce different functional groups into molecules. What I'm going to start by doing is just an overview of the different types of reactions that we're going to focus on in this chapter, where we're going to start with alcohol reactants, carry out a reaction of some sort to demonstrate the variety of different functional groups that we can introduce into products. Because when we're thinking about synthesis of organic molecules, it's always useful to keep functional groups in mind. Functional groups are the language by which we're going to discuss converting one type of molecule into another. So alcohols, to get started with the types of reactions they can undergo, first off, they will undergo so-called dehydration reactions, loss of water, in order to give alkene products. So if we want to convert an alcohol to an alkene product, what we would do is an dehydration reaction. Remember, that was in a type of elimination reaction, and this particular reaction has already been discussed, so we're not going to be discussing it here, but if you go back and review video number 60, that's where you'll get the full details on dehydration reactions of alcohols. Another general type of reaction of alcohols is so-called oxidation reactions. Oxidation reactions are, as the name implies, going to involve increase in the number of carbon-oxygen bonds in a molecule. We will be looking at this reaction in more detail later on, and that will be covered in the next couple of units, which will be videos 89 and 90. The product of oxidation of an alcohol is going to be a variety of different functional groups, including, depending on the type of alcohol that you start with, we can end up yielding an aldehyde, a ketone, or a carboxylic acid, which I'll abbreviate as Ca here, as the final product of those oxidation reactions. You'll notice that all three of these functional groups, aldehyde, ketone, and carboxylic acid, all have a larger number of carbon-oxygen bonds than the alcohol starting material. Hence, that's why we refer to it as an oxidation reaction. It's oxidation. So, in addition to oxidation, in contrast, we can also do reduction reactions of alcohols. In other words, getting rid of bonds between carbon and oxygen. So we will also be focusing on reduction reactions, which are going to enable the conversion of alcohols into alkanes. And we will look at those reactions later on in video number 91. Continuing our theme of building this map of different types of reactions that alcohols can undergo to convert them to different functional groups, we can also convert alcohol functional groups into alkyl halide products. And the way that we will go about doing that is through nucleophilic substitution reactions, and those reactions we will discuss in both units 92 and 93. Continuing on to look at additional types of reactions that alcohols can undergo, we can convert alcohols into ester molecules by carrying out a type of reaction referred to as the Fischer esterification. In the Fischer esterification, we're going to react a carboxylic acid with an alcohol to yield an ester, and we're going to focus on that reaction type onward in video 94. Then finally, to finish off our discussion of reaction types of alcohols, we're going to do the Williamson ether synthesis reaction, named after the discoverer of this reaction. It's going to be a way to convert alcohol starting materials through a couple of steps of reaction into ether products. And so it'll be a way that we can go about converting alcohols into ethers. We're going to accomplish that by first converting our alcohol into an alkoxide. That is, we could think of it as a deprotonated alcohol, in other words, an O-alkyl group where the oxygen has a negative formal charge. We're going to then be using that as a nucleophile to attack an alkyl halide to force the halogen X leaving group to leave, thereby creating a new oxygen-carbon bond, and hence yielding an ether product. So as we look at this diverse array of reactions, giving way to a bunch of different types of functional groups. What you want to think about and keep in mind here is the utility of alcohols as starting materials in chemical reactions. When you're faced with a synthesis problem, alcohols are going to be very useful as starting materials and intermediates in these reactions because we can readily take those alcohol materials and convert them into all these other different functional groups. So you could think of this material that we're seeing here as really a roadmap for going through and enabling the synthesis of these different types of molecules. And it's always useful to keep in mind when you're thinking about syntheses that you want to be able to piece together different functional groups. Thinking about converting functional group A to functional group B, and then when you actually go to do the problem, filling in the exact number of carbon atoms and things like that. But a good way to wrap your mind around how to synthesize molecules is to focus on what functional groups can you interconvert from one to another and get a handle on those types of maps. So with that, let's go ahead and move on to the next units where we'll look at each of these reactions in more detail.